We're on? Excellent. All right, we're here for another Going Deep series. Today we have Anders Vinberg and Ray McCollum, architects in Windows Management Platform Group.
Right.
Thanks for coming on. Talk to us a little bit about management, the problem, and what you're working on today. Now,
Okay.
I know there's this dynamic systems initiative. You could also talk about that a little bit.
Sure.
Next.
Happy to. Yeah, our group, the Windows and Enterprise Management Division, long name, that's because we do two things. We do the management solutions that we sell to customers, enterprise management products like SMS and MOM and a few others. And we also do the management infrastructure that goes into Windows.
Okay.
So those are the two parts of the organization. It's a really tough problem. It's a really important problem for our customers because managing machines is just costing way too much. Now, I've been working on that problem for a long time. I used to work with one of the companies in that space for 15 years. And basically, I concluded back in the 90s that the old way of doing things just wasn't working. And in fact, I went off and did something else for a while. I got so depressed by the whole situation. And the problem that we have in the past is that people will deploy a system. They'll build a system and they'll deploy it, and then they come wheeling in a management solution after the fact.
Okay.
And hope that they can manage it. And the problem is the management systems just never have a clue. They don't know what is going on. Right? And it's a little bit like trying to secure a system afterwards if it's not fundamentally secure. We know that's a problem. Right? We have to engineer things to be secure. Same thing, we have to engineer things to be manageable. And we are now going back and saying we have to go right back in the foundation. When we build the OS, when our customers and ISVs are building applications, and make sure we capture the knowledge about that system up front.
Absolutely.
So I sometimes call it knowledge-based management, just having knowledge of what the system is and what it should be. But knowledge sounds vague. It sounds as if we're talking about people having a little red book of stuff. So we really talk about model-based management, and models are the formal, rigorous definitions of that knowledge. So the driving theme of DSI is that we want to have models of all the systems that are going on, have models be created and maintained, put all kinds of policies into those models, and then we can do an okay job.
Now, when you say models, are these software constructs? Like modeling systems? Is that what you mean?
In effect, that is what we mean. A couple of little differences. In principle, yes, we do construct a model. You know, there are boxes and lines and diagrams and things like that. But the important thing about those models, well, there are two parts. The topology of a system is a key part. What are the components? What are the relationships between those components? What protocols do we speak? What kind of network link do we have? What are the services? That's the basic skeleton of a model. That's the key. If we don't know the topology of a system, you don't get anywhere. But the other part is that we then decorate that model with various policies. So we will have a configuration manifest that says that I want this part of the system to be configured this way. And I'll have a health model for it that says that if this event happens, that means something went wrong and this is what you should do about it. We might have a service level agreement that I want response time at this component to be less than 2 seconds. Right? So that each of these management policies gets attached to the model. And that's how we get order in the whole place.
Outstanding. Now, when you move these systems into large groups, so you have distributed systems, it must get orders of magnitude more complex to manage.
It gets.
Right? And you're famous for the Isness and Oughtness. So thinking about the Isness and Oughtness of a distributed, group of computers working on a problem or a couple problems, and something goes wrong, to figure out what state they're in, what state they should be in, is a pretty dramatic challenge.
It is.
But you're working on that.
That is the problem we're working on. That is the key problem, and it gets orders of magnitude more interesting, and more fun too. Now let me explain this Oughtness and Isness.
Please. Because
whenever I make up words of my own, I have to explain them. So the idea is that if you have a distributed environment, right, you got up at the top, you got developers and you got IT administrators and people like that who define what is going on. They build a system, they create models, they create policies. Those models go into a database of some sort. Right? We usually call it the CMDB, Configuration Management Database. And then they find their way to a management system, and then they maybe to multiple tiers of management system in a large, worldwide company. Eventually, they end up on the machine we're going to manage. So what you have is, in effect, a flow of these models and policies. And I call that Oughtness because it is information about how the system ought to be, right, in terms of configuration and health and service level and so on. At the same time, we have the other flow, which is going the other way, from the system up to the IT administrator about how the system is. So in effect, we have one flow of Oughtness, one flow of Isness, and our job in the simplest level is to compare those two, and whenever they're out of whack, whenever the system is not the way it ought to be, do something about it.
Sure.
So essentially every scenario we have boils down to that simple idea. But the devil's in the details, and for example, like you point out, in the geoscale distributed environment, everything gets more complex. The understanding of the system, the Oughtness, right, the model, is more complex because I now have to describe all the systems and how they relate to each other. The moving the data around is more complex. I have to deal with staleness because there are latency at different stages in this replication program. And how do you define a policy when the data you have is stale? Right? And you got laptops in the environment and they are not even reliably connected. How do you monitor Isness and Oughtness when you have intermittent connectivity and so on? So that a lot of interesting details come up, even though the basic principle is simple.
Absolutely. So, what in a concrete sense, what exactly is this management system? Now, you mentioned SMS and MOM, and so these are automated. These are software constructs running as part of the operating system or as an application that you can run.
Yeah.
Can we talk a little bit about that?
Sure. What we do, like I said, we deliver on two levels, right? Products like MOM and SMS. They are large-scale enterprise systems. They are designed for large enterprises. They wouldn't make sense for a dentist office or anything like that.
Sure.
They're relatively complex to put in, but they're very powerful, and they scale very high. Both of these, SMS, we have customers that have several 100,000 machines, and what they want to do is to get those machines configured right. They want to keep them patched. They want all kinds of controls. They want to schedule them. They want to, it gives you a lot of fine control over that. And MOM is mostly used to manage servers. In fact, our own, Microsoft IT department uses these tools, and we have, I think they manage 7,000 servers with MOM across the world. Okay. And so MOM is keeping an eye on those things and verifying what is going on. And they have very tight requirements on those. For example, they have a service level requirement that no alert from anywhere in the world should take more than 2 minutes to make it to the central console so they can deal with the problem if there is one. So that's the kind of thing that those products do. And those products are, we are busy working on a new generation of those products that are based on the DSI principles, right? So that are based thoroughly on models and so on. They will be released in the next few years.
Excellent.
But we are also putting a lot of interesting stuff into the operating system, right, according to these things. And we'd like to spend a little more time talking about what is going into Vista from the DSI principles.
That would be excellent. So clearly Windows Update, Auto Update, Dynamic Update, these are all part of your umbrella.
Yeah.
And those are the way that we're managing systems today. Now, can we talk about how that will evolve in Vista? Maybe not those specifically, but
Windows Update and Microsoft Update are tremendously important for keeping the market healthy, and they do incredible work. That team has done very nice stuff. Right now we have 200 million Windows machines under management by those products, keeping them patched. And they have a very, very high success rate, sending patches out and so on. So that's very cool stuff. On those products, the changes in Vista are more about how they're being used than about the raw technology. Right? Because it originally was called Windows Update because all we did was patching Windows. And now we have incorporated other Microsoft products. And we've begun to incorporate stuff from some of our business partners as well. Excellent. So that Dell and other people can send out updates to their systems. So that's very important stuff. And we intend to leverage that technology for other things in the future. And I don't really want to go too far on that.
Sure.
It is such a strong foundation for moving information around that we plan to leverage that in many other areas.
And now at the core system level itself, let's talk about, say, the health of the system. So the operating system. Some series of events happen, the operating system has some mechanism. Now, this isn't going to be Windows Update. That's sort of a specific to, you need something, install it, hot, patching. But if the system itself is monitoring itself and something goes wrong, it has to have some sort of mechanism to where it can A, identify that something went wrong, and B, do something about it. So what is that construct in Windows?
The key thing, like I said before, is the knowledge. Right?
Okay.
You have to know what's going on. And actually, Ray, why don't you fill us in on both eventing and protocols and stuff like that?
Sure. Well, in the Vista time frame, as part of the Isness, we want to know what has actually happened on the system, because it's hard to tell if the Oughtness is going to apply until you know what the system is. Historically, Windows has always had an event log. Back in when Windows NT 3.1 came out back in 1993, event log was there from day one. The problem is that the original event log was designed for sort of an interactive GUI-based user who was just going to mechanically browse and interpret in English what's wrong with the system. Well, as we start building these automated systems, it's hard to write software which understands English. And so we've had to work around the limitations for many, many years now. The Windows event log has messages, they get localized in different languages. There's some relatively obscure ways in which you extract the information. And so if you're trying to monitor what has happened to a system, you have relatively complicated software to sort of pretend to be a human and try to figure it out. With the XML revolution, we decided to sort of do a complete rewrite of the Windows event log and say events should be little pieces of XML. That way we can read them, analyze them, query over them, and we can attach them to a schema. We know exactly what that schema means. That's what XML schemas are for. So the Windows event log in the Vista time frame, we have a code name Crimson, I think a lot of people have heard of that, is essentially an XML style event log. As the events are written, they become little virtual pieces of XML in the log. They're not real XML because that would be too inefficient, but they look like XML to the user. The tool sets, such as the Windows Event Viewer or an application like MOM who wants to read the log, can now use XML-type concepts to analyze what's inside the log. They can run queries, they can filter just the events they care about, they can analyze, and they know what the fields mean. There's no English anymore. XML is tagged. It says server name is this, user is that. I don't have to try to extract it from the middle of a sentence.
Absolutely.
And so that's been a major improvement. We've also taken care of some of the historical problems with the event log. The original architecture was such that you couldn't have event logs bigger than, say, 400 megabytes. Well, on some servers, we've seen that the log fills up in 2 seconds. And then people think, well, what am I going to do? Where do I put my events? And so we've had a tremendous number of private logs. To get around limitations, people just don't put their stuff in the event log. In fact, in the years I've been here, since '93, every year, don't put that in the event log. You're flooding the event log with this information. All the good events are disappearing because it's your event over and over again 1,000,000 times. And so over the years, people just quit putting important information there. So getting rid of some of those size limitations, getting rid of the problems with the semantics, and the separation of logs. The Windows event log only had 3 logs. And while you could invent your own log, everybody was afraid to do it because nobody would know where it was or what it was called. So we've formally introduced the notion of application-specific logs in the Vista event log. There's some shared logs, which are mostly for backward compatibility, and each application, each service can have its own log with its own set of schemas, and you don't have to worry about filling it up because it has a 4 terabyte limit or something insanely gigantic. So the other thing we've done, which is really important to prepare the way for some of this future distributed technology, is we've built in event forwarding. Up until this time in history, the event log was still local. You'd have to download various management agents to analyze, extract, and get the events up to some machine where they could be analyzed. As part of our web services effort that we're doing at Microsoft, we've built in the ability to automatically forward events from the source machine to some destination server to essentially replicate the log. In addition, you can say, I don't want all the events. I just want events from SQL Server between this range and this range, or I just want events from Exchange, something like that. So not only can you forward the logs, you can forward them to multiple destinations, you can select which events you care about, and they get collected, and then tools like MOM, SMS, and such can read the logs from those locations. So part of the infrastructure of getting the Isness around to where it's needed.
In fact, Ray, if I can jump in there for a moment, there's sort of a high-level point here. What I found in my years in management is that management people always think that they have a really unique problem. And what I keep finding when I look around is that many of the problems we have in management are similar to other things. And this whole question of protocols that Ray is talking about is a good example of that, because it became apparent when we were looking at management protocols is that in the new world, with large-scale distributed environments and so on, a couple of requirements we have on management protocols. We want them transport independent, we want them loosely coupled and flexible, we want them secure, they need to be able to go across trust domains if I'm cooperating with a partner and so on. Well, all of those requirements are the same as the requirements that we have for other protocols. Of course, right? Management is not that special. And given that that is the case, the solution for those kind of requirements in the new world, in the new distributed, fast-moving world, is web services. So of course, web services is a good answer for management as well. So this is a place where we didn't need to invent our own technology. All we have to do was decide to use the technology that the company has put so much investment in. So we defined something called web services management, which officially has the status of a standard. But in reality, we didn't invent a lot of stuff. We just defined sort of a profile of saying, this is how we're going to use the standard web services stuff. And that's very exciting to me, because anytime we don't tend to invent a lot of new stuff, but can use standard stuff, so much the better.
Interesting. So now, are you saying that if I have a system of multiple machines, and are they periodically sending information out to these web services when like events happen, or do I have to request that happens?
So let me address that. In the case of events, let me back up just a moment and sort of give you the taxonomy of WS management. We identified that 90% of management products, like MOM, SMS, and some of our competitors, 90% of the operations involve taking a measurement of some status of the system. I want to find out how much memory is being used. I want to find out what a particular setting is. I need to be able to get something. In some cases, there's a whole series of those. For example, processes, there's a list of those, not just one process. So I need to be able to sort of enumerate some item. And that's one set of operations which we see over and over and over again. So WS Management took some of the basic web services specs which address these areas and said, that part of management, we're taking these specifications into WS Management for getting and enumerating things. If you think about it, the only distinction between one item and another is the identity of the item that you're getting. If I say, get me the CPU usage, or get me the amount of free disk space, the only difference is the concept of get is still there in both cases. I'm identifying what I'm getting. So WS Management has said, hey, getting and enumerating are basically common verbs, common concepts. All you have to do is identify what you're getting. So the protocol is actually quite simple in that it identifies these verbs as sort of common things. The other part of WS Management is the eventing. Events flow the other direction. I don't get the event. I want the event sent to me when it happens. I don't want to keep checking all the time. That uses up network bandwidth. I would rather essentially ask you, please send me this event when it happens, and I'll sit around and wait for it. So the paradigm introduced by web services is called a subscription. It's just like a magazine subscription. I subscribe to it. When the event happens, I get sent my copy of the event magazine. So WS Management incorporates both this get enumerate on the one hand and then this subscription mechanism for events on the other. So the way the tools work is on the receiving end, you point to the machine and say, I would like to subscribe to SQL Server events. As they happen, they get delivered. And like any other magazine subscription, it expires after a while and you have to renew it. The reason we do that is because taxonomies of networks are changed sometimes, machines are taken down, and we don't want this machine forever trying to send events and uselessly never succeeding and chewing up its own. So we eventually want it to give up. So if the subscription has a duration of 3 days and nobody renews, it gives up. And if the receiver doesn't care about resubscribing, then everybody's happy. The system cleans itself up.
Excellent.
Now, actually, there is an important thing hidden in what Ray is saying. Ray owned this whole thing, and it was a very interesting project to do because we really wanted to make it clean and simple, make it small. And you know how it is when you're designing a system. It's a lot easier to make a large and complicated system than to get it small and tight.
Absolutely.
Mark Twain had some joke about that long time. I don't have time to write you a short letter. I have to write a long one. So what we did here is we really worked very hard. The first draft of the design was quite complicated, and then we spent quite a lot of time cleaning it up, simplifying it, reducing things, deciding things we didn't need to do because we could use something else. And the end result of that is very cool because it is small enough that Intel can put it in silicon. And Intel has very tight limits on themselves because Dell will yell at them if they spend more than $1 on silicon. Right? So we have come up with a protocol that can be implemented in hardware. And that's very cool.
Wow.
Because this means that we can manage a machine before it has booted, right? Or before I even provisioned an OS on it, or just in case after it has crashed. Right? Anytime when there is not an OS on the machine, we can still talk to it.
Wow.
And when we do that, it doesn't matter if it's a Windows machine or not. So we had a funny thing last year, about a year ago. We introduced this thing at our conference, and we had put a Spark machine, a Sun machine with Solaris on it. We don't know nothing about Solaris or about Spark, but this thing had implemented WS management in Silicon. And we actually had Steve Ballmer up on stage, and he went up and broke the machine. He pulled the fan out of the machine, so it started overheating. And then we had Mom, our product, detected that the machine was overheating, even though it doesn't know anything about Spark or Solaris, and reached out and shut down the machine so it wouldn't burn up.
Excellent.
And it did that just because we were able to get a protocol simple enough so we could put it in Silicon. It's very cool stuff.
That's amazing.
Over the weekend, I saw a vending machine that had a crash screen. It wasn't ROS. So this could have been used to reboot the machine remotely? Or
Absolutely, yeah. We've actually shown a number of demos in which you subscribe to blue screen events from Windows. And anything, we actually have test cases in the lab in which we blue screen, the Silicon sends an event, and then the receiving end can actually execute a reboot and get the thing back online. So a lot of our customers are excited about the potential for systems administrators not having to come into work to restart machines. They can do it from home on their laptops as long as they have a secure connection.
That brings up an interesting question. In the rare case that Windows will blue screen, especially in the Vista timeframe,
Right.
when something like that does happen, so the hardware, which is amazing, so the chip knows something's wrong, right? This is the lowest you can get in the system knows something's wrong. But what about getting the information about why it blue screen? Where is that? Where is that information located in the packet that's sent to you about something's wrong? So how do you get that? Is there an event? Is there there's no log to read, right?
Well,
the machine's blue screen.
So in some of the first, I can tell you where it is today and where eventually it will go.
Sure.
The chipsets actually have a small microscopic event log of their own, maybe 100 entries.
Okay.
And so when you subscribe to the chipset's event log, it's just like subscribing to the Windows event log. You'll get an event with as much knowledge as they have about what may have gone wrong. They know about controllers and other pieces of hardware.
Sure.
Sometimes a blue screen is a device driver failure and they won't know about it. They'll just know Windows isn't responding. And then when Windows has its crash dump and it comes back online, then the Windows event log at least, after you get the machine rebooted, you could query the event log and find out what Windows thought was wrong. So by using sort of the two in tandem, you could eventually diagnose what happened without actually having to be at where the machine is.
So now,
I also should jump in one sort of big perspective. If you get back up to 30,000 feet for a moment,
Great.
One of the goals that we have overall in this situation is to eventually get away from the problem of grubbing around in failure logs, right? Because we won't have fewer failures. And the big picture goal we have is for self-management, right? Meaning we want to get the operator out of the business of futzing around with these machines. As we have hundreds of thousands of machines, you don't want to deal with them manually. Now, if people talk about self-management, we usually talk about sort of a range of things from self-deployment to self-configuring, self-optimizing, self-protecting, self-diagnosing, and self-healing. Right? And all of those are important, and we are working on all of those. But if you think about that list, at one end you have prevention, and at the other end you have cure. And it's just like when you go to a doctor, right? Prevention is more valuable than the cure. So that if we can automate the deployment of systems, the provisioning of systems, putting the OS on them, configuring them right, making them optimize themselves, we will have fewer failures, right? And we won't have to deal so much with the failure logs. And that's why the other side of WS management is so important, that we can use it to talk to the machine before it has anything on it. If you go in and look at a big enterprise today, they buy computers by the rackful, right? They will buy a rack and there are 256 blades in there, right? And they all have to be provisioned. They all need to get their OS laid down on them. They need to get connected to the storage area network and so on. There's a lot of stuff to do there, and this will help us deal with that end of the chain as well. And then the other aspects of model-based management allows us to make sure that the systems keep configured correctly.
Sure. So I just wanted to point out that we joked about this once in an interview we did with the Singularity people, but really what you're saying is we are getting closer to a homeostatic operating system, right? A system that will be able to take care of itself at some point. This is the beginning.
Yes.
So now can we talk about the future in broad strokes? This is not, product related. These are not promises. But so where are we going? And specifically, I was curious about virtualization and its role in the future of management.
Virtualization is
Big term.
Yeah.
But let's talk about Windows virtualization, hypervisor group.
it's very interesting stuff, and we put together last year. We put together a team of people who really dug into this question of what does virtualization management really mean? Because all we knew is Bob Mugler came down and told us to fix virtualization management, and we all said, "What's that?" Nobody knew. So because the first reaction people have is that a virtual machine is just like a physical machine. So if you can manage a physical machine, we can manage a virtual machine. And so on the first approximation, that's correct. But when you drill into it, it's not correct at all. There's a whole bunch of other interesting issues that come up. Some of it is fairly straightforward. If I have the hypervisor, it has a bunch of functions. I can create a new VM. I can give that VM resources. How much of a CPU should it have? How much virtual memory should it have? Blah, blah, blah. And we need tools to help people do that. So we want to we're in the process right now, building a tool that allows you to manage all your physical and virtual machines and, in fact, deploy workloads on them under different rules. Right? I have this particular workload. It's a business application. It needs this much. I want to deploy it right now. Look around, find out where you have some free resources, and then put it there. Move the bits over there, create a VM, start it up, run it, keep an eye on it, and when you're done, move it somewhere else. So that's a very exciting project going on. We're building the product. The code name is Crimson.
Okay.
Carmine.
Carmine?
We just talked about Crimson. No, this is Carmine. And by the way,
Interesting.
That's his alter ego.
It's Carmine?
It is Carmine. And the reason is that the code name for the hypervisor project is Viridian. And Viridian is actually a green color. And so we looked in the color spectrum, and Carmine is a red color. So we put
Wow.
So in any case, so that project is going on, and it's scheduled to ship 07 next year. And that's about managing the virtual systems themselves. But there are a lot of other interesting things that came up that sort of where virtualization had impact on the other solutions. I'll just give you one interesting example. We have MOM, which is the health monitoring system. And MOM is self-configuring. Right? What it does is it looks on the machine, finds out what is there. So if it figures out that you've got SQL running on a machine, it figures out that it has to put the health model for SQL on that machine so it can monitor SQL. It does all of that automatically. Now, the way it does that is that it periodically runs an inventory scan and finds out what's going on in this machine. Not only is there SQL there, but how many SQLs do I have, and how many databases do I have, and so on. And all of that is automatic, no hands-on. The problem is that MOM today does that by scanning every 24 hours. Because in today's world, with physical machines, it is a big job to provision a new machine, and people don't do it very often. So 24 hours is fine. Nobody's upset if it takes us 24 hours to figure out what's going on. But the whole idea with virtualization is that we want to be more dynamic. We want to be able to provision a new machine, run it there for a while, take it somewhere else. So 24 hours is going to be too slow.
Sure.
Right? So we have to rethink MOM. MOM might never figure out what the hell is going on otherwise. So, and you can't just crank down the interval, right? If you start scanning the machines every 5 hours, because a scan is expensive, you don't want to do that. So in effect, we have to switch over from a regularly scheduled scanning model to an event-driven model, so that we notice that when a new VM is created, MOM is notified about that and then does a scan. Well, it turns out this is not a problem. MOM, a schedule or an event is the same thing, so it was very easy to make the change. But the important thing is we had to recognize that we had to make that change, because in this case, the change is not driven by technology. Right? It's not anything in particular about the VMs that make this happen. It is driven by how we expect that people are going to change in how they use their systems. Right? So we had to sort of anticipate that change and prepare MOM to be ready for a more fast-moving world. Sure. And there's a long list of little things like that, where the way people are going to think about their machines is going to change. It'll take them a few years. This is not overnight. It'll be 5 years. But we expect that 5 years from now, the way people use their systems will be very different, and we have to be prepared for that on all kinds of fronts.
So now, when a new virtual machine is created, as far as the operating system as the host, I guess is that what you call the operating system? The virtual machine is the guest.
Yes.
To it, it's just a process, right? So how does mom, that's monitoring the host, how is mom able to actually get inside and monitor what's going on in the virtual machine? Because let's say that's where I'm hosting my SQL Server,
Right.
and not on the host.
Right.
So how does that happen?
That's very interesting, and it's very natural to think like you're thinking, but it's wrong.
What else is
So, no, but the cool thing is this, that if you have a host that is hosting all these virtual machines, you want to monitor that one. Right? You want to put a mom agent in there. It's going to keep an eye on the resources of that host and what is going on and the problems there. But the stuff that is going on inside the virtual machine is invisible to the host, and it has to be for security reasons. Right? Because if you think about it, the OS that is running inside the host, it may be running some very sensitive business process. Right? It may be in a different forest. Right? Hey, it may be a different operating system. It may be running Linux in there or something like that. So there's no way that mom in the host can peek inside the guest. In fact, the hypervisor people are very adamant about that. There is no backdoor. There's no way we can sneak in and take a look at what's going on in there, because we need to be audited by security people. So if you're going to manage SQL inside a VM, you have to put the mom agent in there.
Okay.
And the idea that you can sort of peek in over that wall is just, security people get all antsy about that.
Sure, which makes perfect sense, actually.
So this whole thing is very exciting, and you know, when the marketing people talk about our goal, what is it we're trying to do if you go out a number of years? We talk about self-managing dynamic systems. And self-managing is all about collecting the knowledge, collecting the models, putting in these automated processes to do it. And dynamic systems is about being able to respond to new business requirements. And so what I would say is that virtualization is probably the key enabling technology for dynamic systems.
Sure.
And models is the key technology for making them self-managing. And web services protocols is the key to connecting the whole distributed web. So these are the three fundamental enabling technologies for the new world.
Now, and underneath the covers, the web service is a wrapper over WMI. I mean, how does that work? So WMI, clearly you're not going to fit on in Silicon.
No, WMI has, of course, has been historically present in Windows since 1995, I guess. It was in Windows 95, 98. So it's an important surface area against which we take the measurements. As I said back a while ago when we were talking about WS management, I need to be able to get measurements in order to check my isness. WMI has been the source for a lot of that information. So what we've done is said that WS management sits between the user and WMI. I talk to WS management for information. The WS management stack is smart enough to know, that information that he wants is actually in WMI. I'll go get it, translate it to XML to be compatible with web services, and then put it on the wire.
Sure.
So WS management is surfacing all the information currently available in WMI, all of the settings that you can make, all of the methods that you can execute, like rebooting the machine. That's all available automatically mapped into WS management. Over time, we're trying to make it easier to write WMI providers, because that's been the historical problem with WMI. A lot of people want to use it, a lot of these tools consume it, but it's hard to write a provider, a lot of work. You have to understand DCOM, interfaces, IONOWNs, ref counting, and all the other stuff.
All that old stuff.
So we've made some big improvements using the .NET technology and how you write a WMI provider. We went from one extreme of extremely difficult to now extremely easy. The basic idea is that you just write a .NET class and you put a tag on it and say that's a WMI object. And a few other little hints are necessary, because when you write a .NET class, some of the things on there probably you don't want WMI to look at. They're just there because you're writing your code. So we basically say you put a tag on the class and you put a tag on some of the properties saying, yeah, that's WMI, that's WMI, that's WMI. That's it. By putting these attributes on the class definitions, the new technology, your .NET class becomes a WMI provider.
Excellent.
As easy as it could possibly be.
Right on.
Yeah,
That's fantastic.
This is really cool, because it's easy for us. We're part of the Windows organization. It's easy for us to focus on on just improving the manageability of Windows. But it's not about Windows, it's about the whole environment. Right?
Mm-hmm.
And that means that we need, just like we need to put manageability into Windows, we need to help our customers put manageability into their systems, the systems they're building. So we actually, in our team, have a very close relationship with the Visual Studio team and the .NET team to make sure that these management principles make their way back in there, so that it'll be very easy when you're in Visual Studio to make a system manageable.
Cool.
And, you know, sometimes when I talk about this, I get a little faint because we're talking about a huge revolution. We're talking about changing the mindset of the whole industry to realize that you have to put manageability up front into the system. You can't manage it after the fact. Well, culture shifts and revolutions take a long time, and it'll be a very long time until we're all done with this whole problem. But you have to start somewhere.
Sure.
And we decided to start in Windows, and then we will go out to the rest of Microsoft and the rest of the world. And because of that focus, we have driven quite a lot of these requirements into Vista. And well, take this simple thing about eventing. It is now an engineering requirement for any piece of Vista code that it has to have an event manifest that declares all of the events and the XML schema for those events. And a whole bunch of other similar things. So we're driving back to in effect, require of the developers that they have to do these things. And,
Excellent.
It's been very exciting to see that happen. You know, I had a conversation a while back with David Vaskevich, who is CTO. We were talking about, he was sort of taking inventory of what are the big problems here and there, and management is one of the big important issues we're working on. He had many others. So he asked me sort of to list what are the big problems I face. What's the number one problem I face? And what I told him is that the number one problem isn't technology. The number one problem is adoption. And we can provide all kinds of cool technology, WMI and WS management and Crimson and this and that. But if we can't get people to make use of it, it's nothing. Right?
Yeah.
So the fact that we are able to drive these requirements into Vista is a very important part of making it meaningful.
Absolutely. So it's actually, Vista then is basically bringing Isness and Oughtness closer together.
Yes.
Right? Because I mean, you have a better understanding of Isness if people are following certain guidelines and giving you the ability to know what is happening on the machine.
Absolutely. It's
Or Oughtness, I meant.
It's bringing it closer. It doesn't do the whole job. It doesn't bring it all together, but it's a very important step. I'll give you another example of Oughtness too. Group policy is not a new technology. We've had group policy for a long time. Very valuable product. It allows IT administrators to say, I want my systems to be this way. I want the firewall to be open on my machines. Things like that. We've done some technology changes to group policy, but in Vista, the most important thing we did to group policy wasn't about the technology, but about the usage of it. So we have driven throughout the environment much greater group policy enablement, because group policy requires that each team put some logic into the code to make them group policy aware. And we now have a huge number of settings in the OS that are group policy enabled. And that's another example of these things. It's not the technology that makes it happen. It happened because we had a bunch of program managers who went out there and talked with everybody and convinced them that this is a really important thing to do. So adoption is the key benefit there.
Excellent. Well, this has been enlightening.
Cool.
So
enjoy it. We will
We'll
talk to you in 10 years when all the problems have been solved.
Totally, that would be amazing. It would be really nice to talk. Again, once you have in further iterations, and we realize that operating systems are just snapshots of where they're going to end up. And Rob Short talked about that in his interview with us, and that was a good way of putting it.
Yep.
This is just a snapshot where we want it to go.
Yeah, we have the whole team right now. Well, not the whole team. A big part of the team is still working on dotting the I's and crossing the T's of Vista. But we have put together the planning team, and we're working on the next generation of the OS, as well as the next generations of the enterprise solutions. So there's a lot of exciting stuff coming, and we'll be very happy to talk to you about that later on.
Great. Thank you very much for your time. I'm sure you have a lot of work to do. Appreciate it.
Thanks a lot.
Thank you.
Thanks.
Take care, Ray. Appreciate it. Grand. See?
Okay.